All right, thank you so much for coming in, everybody. The syllabus that we have, the one that I saw, it has moles, mole conversion, empirical formula, finding relative mass, basically relative atomic mass, relative molecular mass, percentage mass, and of course moles at the end of the day. That's what this is about. Your syllabus is really short, and that means we should be able to do questions of all of those. But at the same time, this also puts you under somewhat of a pressure for December, because by the time December comes in, which is not far, you will have to do this as well as 3 other chapters, I'm guessing. So all the best, and let's just start with this without further ado. Okay, so the very first idea where we begin is the idea of what an isotope is. That's a definition you should know. Of course, it's usually not asked for in grade 10, but that's where it all begins. So does anybody know the definition of isotope? What are they? Yes. So they have the same proton number. Yes, that is correct. So same proton number, that is important. So there are 2 atoms. I'm writing NO for number, and they have different number of neutrons. Now, of course, in your exam, you can't just write NO dot. You have to write the full word, but abhi main usko same proton number, different number of neutrons. Same proton number ka matlab ye bana that this is same element. Okay. And different neutron number ka matlab ye bana ki uska different mass hoga. Okay. So that is the idea, that isotopes have different mass, but they're the same element. They have the same chemical properties, because chemical properties depend on the last shell. तो इस वजह से उनकी properties पे फर्क नहीं आता. Every isotope will have its own mass, right? I'm sorry, Daniel, what do you mean? I am sharing the screen. I hope you. Yeah. So every isotope has its own mass, and that mass will obviously determine whether it's heavier or lighter and all that. So let's take the example of hydrogen. Hydrogen has 1, hydrogen has 2, hydrogen has 3. So we call them hydrogen 1, hydrogen 2, hydrogen 3. These also have another name, but हमें उसकी आज जरूरत नहीं है. अब अगली बात ये आती है कि दुनिया में when you take hydrogen, which atom are you more likely to pick? Is it hydrogen 1, hydrogen 2, hydrogen 3? Which one? Like if I say a random hydrogen atom, what's the chance? So that is called abundance. कि दुनिया में this particular isotope, how abundant is it, or out of 100 of these atoms, how many would this one be? So again, I don't have the exact value, so I'm just making it up. Let's say दुनिया में 98% ये वाला होता है, 1.9% ये वाला होता है, और बाकी जितना भी है वो ये वाला होता है. So how will we figure that out? We'll simply subtract it from 100. So the total has to be 100%. 98 plus 1.9, 99.9 हो गया. And that means this is 0.1% in the world. Now, everybody should have periodic table and a calculator with you while you're practicing these questions, okay? So we use these while every isotope has its own mass and all that, but we can use it to figure out the relative atomic mass. So that's the next term, relative atomic mass. Now, relative atomic mass, the word relative in here basically means comparison. We are comparing it to one of carbon 12, ठीक है? 1 unit of carbon 12. And atomic mass तो आपको पता ही है atomic mass क्या होता है. So अब आप क्या करोगे? It is, इसकी definition भी important है, exam में आ जाती होती है 2 marks की. So it is mass or average mass, naturally occurring isotopes or natural isotopes. So that's one part, 1 mark, compared with carbon 12. ठीक है? So ये आपके notes में भी लिखा होगा. In fact, carbon 12 नहीं, 1/12 of carbon 12. तो आपके पास ये परसेंटेज आ जाएगी. तो AR निकालने का तरीका वो आप इनको मल्टीप्लाई करते हो. सो 98, अगर इसका मैं AR निकालूंगा तो इसका AR होगा 98 times 1, 1.9 times 2, 0.1 times 3, add it all up, and because it's percentage, divided by 100, and that will give you the final value. ठीक है? तो इससे हमारे पास ये आ जाएगा. I don't think limiting reaction yield is in your syllabus, because the one that the updated syllabus that I got, it didn't have that. But it might be different for phase 1. I didn't get that one. So if you have any updated syllabus, can you send that to me? Yeah. So अब इसको हम calculate कैसे करते हैं? we just take that और उससे हम solve. So I have a worksheet here that has all the questions from the last 4 years. तो हम उनको one by one देख लेते हैं. Yeah, so here's a question. The question says that, so I'm having some issue with the copy paste here and off nahi chal raha hai. So it's saying hydrated sodium iodate. So sodium iodate का formula उसने दे दिया है, that is NaIO3XH2O. That's what it says it has. और अब वो आपसे कह रहा है कि find the value of X if MR is 288. अब MR क्या होता है? MR is the sum of all the isotopes. जो भी उसमें atoms होते हैं सबका mass हम add कर लेते हैं. So all right, it might be in the syllabus of phase 1, so मैं उसके questions करवा दूंगा. All right, so let's just calculate this. So what you have to do is, you know the MR, right? So just calculate all of this. So I have 1 sodium. So what I try to do is I add all the atoms. पहले मैं उनको list कर लेता हूँ और फिर मैं उनको add कर देता हूँ. So sodium plus iodine plus 3 oxygen, ठीक है, ये हो गया, plus X water. I'm not dividing water into 2 hydrogen, 1 oxygen because that's pretty straightforward. हमें वो आता ही है. And this is all going to add up to 288. So I consult the periodic table. My values are 23. Iodine ka, I think 127 hota hai. Let me check. Yeah, it is 127. And 3 times 16 for oxygen plus X times 18 for water. और ये 288 आ गया. And that's a pretty straightforward linear equation. आप इसको solve कर सकते हो, right? So you'll just add it all up. X को subject बनाना है और आपके पास X की value आ जाएगी. So this is a question from your, I think 2019. Yeah. Let's see अगर इस तरह का कोई और question आया हुआ है. ठीक है. So basically आप MR की calculation, it's pretty straightforward, मुश्किल नहीं है. So let's move on to percentage mass. Okay. Percentage mass क्या होता है? You take whatever element you're more interested in and you compare it to the total mass of the thing. Okay, that's what you do. So for example, in the case of what you call ये question है 2020 का, okay, you have zinc phosphate and they want you to figure out the percentage of zinc in it. So zinc phosphate का formula दिया हुआ और वो आपसे कह रहा है कि इसका percentage mass निकालो. So again, because you're interested in zinc, so you'll calculate कि अच्छा zinc मेरे पास 3 है divided by the MR of the thing. So MR is also important. So I have 2 phosphorus, I have 8 oxygen. Notice that I'm multiplying these two and multiplying 1 with 2 to get the total number. Okay. So now that I have that, I can easily figure this out, that this will be multiplied by 100% for percentage mass. I'll need the periodic table again. So zinc is 65. So 3 times 65 over 3 times 65 plus 2 times phosphorus is 31. And oxygen is 16 times 100%. So that will obviously give me a value. So this is the percentage of zinc in this particular compound. Now, exam में वो इसको किस तरह से check करता है? Obviously, give you a 2-mark question कि find the percentage mass of this thing. But उसके अलावा वो आपसे इस तरह का question पूछ सकता है that what mass of zinc can be extracted from 10.6 kg zinc phosphate or something like that. So that's a mass that you have to figure out. Now, again, that's pretty straightforward. You already know the percentage. So we'll calculate it. So 3 times 65 divided by the whole MR, which comes out to be 50.6%. So that tells me that the total is 50.6%. So I'll just multiply 50.6% by 10.6 kg because I know that 50.6% of whatever mass I have, that is zinc. So I'll get zinc from here and that will be equal to 10.6 multiplied. Yeah, we get 5.37 kg. So that's clearly telling me how much mass I will have of this thing. Okay. Can you try to do a question that's similar to this one? Yeah. So the question says that what mass of zinc is there in 30 tons zinc sulfide? Okay, so go on. This is a 2-mark question. Pretty straightforward. Go and do it. So we don't know how much zinc there is. So what we can easily do is, so there are two ways of doing it. In fact, three ways of doing this. So one method is that you first find the percentage of zinc. So MR of this thing is zinc plus sulfur. So that is 65 for zinc. Sulfur is 32. So that is 97. That's the total mass, the MR. And now I know that I have 30 tons. Now you don't have to convert it to grams or kgs. Okay. You can give your answer in tons if the examiner says tons. अगर वो आपसे grams कहता है तो just remember that one ton is 1000 kg or 1 million grams. 10 power 6 का मतलब million होता है, 10 power 3 का मतलब 1000 होता है, लेकिन उससे फर्क नहीं पड़ता है because yes, Kudus is right that ये उसने सिर्फ हमें कंफ्यूज करने के लिए दिया है कि कैसा यूनिट दो बच्चों को जो उन्होंने जिंदगी में कभी देखा नहीं. So we have 97. So the total is going to be zinc is divided by MR times 100% if you want to find the percentage mass, or you can just do it directly, multiplied by 30. So that will give you 65 over 97 times 30. Another way to do this same question would be that you use a ratio method. You'll be like, okay, when I have 97 tons, I have 65 tons of zinc. Notice that it doesn't matter. It could be grams, it could be kilograms, it could be any random unit. But because you have a ratio there, वो कोई भी unit हो सकता है. So 97 tons gives you 65, so 30 will give you X. And you can also do it like that. So ratio method works like a charm every single time. So you can use that as well. ठीक है? So ये हमारे पास एक बड़ा simple सा question है इसका. So that's percentage mass, that is finding AR, that's finding MR. So as you can see, कोई इसमें बहुत ज़्यादा confusion होनी नहीं चाहिए. But in case कोई question है, तो I'm here. पूछें. In fact, if you have any question and you want me to solve it with you, just feel free to, like, you can WhatsApp it to me. तो वो हम उसको वहाँ से देख लेंगे. Okay, hold on. Let me get another question. Okay, I'm going to give you a question जो हमने class में किया था. Class में, if you remember, we talked about two fertilizers. हमने कहा था कि we have two fertilizers. एक है ammonium nitrate और एक है urea. So urea was this. Now calculate percentage of nitrogen in and justify which one is a better fertilizer. Remember, plants need nitrogen for growth. So calculate कि ये कहाँ से होगा. ठीक है? Just take 2 minutes. उसके बाद we'll move on to moles. Yes, Daniel, you're right. First is 35%. And yes, Daniel, second is 46.7%. Round it off to 3 significant figures. Rounding off में बहुत से बच्चे ना moles के questions में ना, it's important to round off at the right time. Because if you round off too early, your answer will be off and the examiner might not give you the mark. So what I recommend is that while you're solving, during your steps, round off to 4 significant figures. But for the final answer, give that to 3 significant figures. If you want to round off. वरना तो आप round off करो ही ना, calculator use करते जाओ और end पे जाके round off कर देना. So that's what I would recommend. So that is rounding off. Okay. So yeah, in case you did not understand, what you have to do is first calculate the MR. So मैं ammonium nitrate का पहले कर लेता हूँ और यूरिया का उसके बाद कर लूँगा. So CONH2. Okay, so the MR, that's the first step. So it is 2 nitrogen. Notice that I'm adding all of them up and we just calculate them. So 4 hydrogen, 3 oxygen. So that's 2 times 14 plus 4 times 1 plus 3 times 60. And this will come out to be 28 plus 4 plus 80. Now, nitrogen is going to be just this 2 times 14 part. So that is 28 out of 80 times 100%. So yeah, that is 35%. Okay, now I do it for urea. MR is going to be carbon plus oxygen. And then I'm going to multiply this inside. So 1 times 2 is 2 nitrogens. And 2 times 2, 4 hydrogens. Okay, so that's 12 plus 16 plus 2 times 14 plus 4 times 1. So this will be 12 plus 16 plus 28 plus 4, 60. And out of that, again, nitrogen is this part. So it's going to be 2 times 14, which is 28 over 60 times 100%. And that is the percentage of nitrogen. So this will come out to be 28 over 60. So 46.7%. So clearly, based on this, you have to give the values of both of them, because examiner said that calculate percentage of nitrogen in each. So you calculate it for both of them, and then you justify that because nitrogen has a higher value in urea is a better fertilizer for that reason. Okay, so I hope everybody's clear when it comes to percentage mass or any such thing. So the next topic is super important, and that is empirical formula. Okay, now empirical formula की definition भी आनी चाहिए और उसको calculate करने का तरीका भी आना चाहिए. Hold on, just give me a minute. Okay, so empirical formula definition बहुत सिंपल है, हमने लिखवाई भी थी क्लास में. इट इज द फॉर्मूला दैट गिव्स द सिंपलेस्ट रेशियो. तो आप उसको देख लेना. अब कैलकुलेट करने के लिए आपके पास इसमें दो स्टेप्स होते हैं. स्टेप 1 इज डिवाइड बाय AR. रिमेंबर इट हैज टू बी रिलेटिव एटॉमिक मास. कभी भी उसको MR से डिवाइड नहीं करना है. सो फॉर एग्जांपल, इफ यू गेट हाइड्रोजन यू डिवाइड बाय 1 नॉट 2. इफ यू गेट ऑक्सीजन यू डिवाइड बाय 16 नॉट 32. इट हैज टू बी द रिलेटिव एटॉमिक मास. The reason for that is that within a compound, oxygen is not existing as oxygen molecule. It's existing as oxygen atoms joined together. And that is why we will take the mass of the atom. Okay. So that's the first step. Second step is you simplify. Ab simplify karne mein na, there are some problems that students face based on what numbers you get. So the first step is to divide by smallest value. So that is one option that you have. You don't have to do it, but this is one option that you have. And the second option is that multiply to get whole numbers. Okay, so you basically have two ways of simplifying. One is you divide by the smallest and hope that you get a simplified ratio or a fraction that you can easily convert. If you don't get that, then what you can do is multiply with some random number. 1 multiply by 2, multiply by 3, multiply by 4. Usually 4, 5 भी नहीं आएगा आपके सिलेबस में, 2 या 3 आता है. But in case 4 आ जाए, 5 आ जाए, no problem. Just multiply the whole thing by that and you will get a whole number. So I'm going to give you some examples of that. Let's say आपके पास आपने सारा कुछ किया और आपके पास आंसर आता है 1:1.333. Now what do we do in this case? I can't round it off to 1. 1:1.33 को मैं 1:1 नहीं बोल सकता हूँ. I can't round it off. So what I do is कि I can choose to divide by 1, but यहाँ पे तो ये काम ही नहीं करेगा, because if I divide it by 1 and divide by 1, I'll get back to the square 1. I can't do it. So I can choose to multiply with some number to get a whole number. And for that, what I can do is I can triple the whole thing. I can multiply the whole thing by 3. And if I do that, I'll get 3:3.999, and that I can write as 4. So 3:4 will work. If you have the more modern calculators, they already give you answers in fractions, so you can use those fractions to figure out what the answer is going to be. Okay, so I'm going to solve a few questions from past papers for this. So uske baad hum usko dekh lenge. Okay, so this is a question from 2019 again, and the question is phrased in a way that might be confusing. So the question says a hydrocarbon contains 88.9% carbon. Find its empirical mass. Oh, sorry, empirical formula. A problem is कि उसने हमें 100% तो बताया ही नहीं. उसने हमें कहा कि कार्बन 88.9. तो अब हाइड्रोकार्बन कितना होगा? The remaining is going to be hydrogen, right? Right? So that is the important thing, that hydrocarbon, hydrogen is the remaining thing. Oh, okay, you've done this. Okay. So then, so because one is hydrogen, the other is carbon, hydrogen is going to be 11.1%. This is going to be 88.9%. The first thing we do, we just ignore the percentage sign. We don't care about it. Now we divide by the AR, as I said, AR, not MR. So divide by that. I think this will be 11.1 and that's it, 5.5. 7.4, sorry. Okay, so what do we do in this case? We can choose to round it off, like we can divide it by 7.4, divide by smallest, right? I'm choosing the first strategy, and that will give me 11.1 divided by 7.4, that is 1.5, and this is 1. Okay, Daniel, I don't get, where do you get the 3.7 from? I don't understand. Now, I don't have a whole number now, but what I can do is I can double it. If the first strategy doesn't work, try the second strategy, double the whole thing. Okay, so if I do that, I get this whole thing multiplied by 2. So this is 3, this is 2. So my answer is going to be C2H3. Okay, so if the first strategy doesn't work or it gives you an answer that is not final, you can always use the second strategy. Okay, but together they will always help you find the answer. Okay, all right. So that was like empirical formula. There is another question of empirical formula where they ask you to calculate the MR. Like they give you the MR and they ask you to calculate. Okay, so this is a question from May, June 2019 again. And this is an interesting question because it has 3 parts, all of them dealing with this. Okay. Yes, feel free to WhatsApp the question that you want me to solve here. Okay, so let me do that. Now remember one thing, if you ever get, so for example, in this compound, let's say the second part was that if MR equals 135, find molecular formula. So this is the second part of this question, if it was. So how will we do that? Again, you need the empirical formula. You already have that. Then you need the empirical mass. Okay, so this one is empirical formula. The empirical mass is going to be 2 carbons, 3 hydrogens. So that is 2 times 12 plus 3 times 1. That's going to be 27. Okay, so empirical formula is 27. And I have MR 135. So always remember that what you have to do is you have to divide MR by empirical mass and multiply that by your empirical formula. Okay, so I'll do that. This will give me 5. So C10H50. And that is my molecular formula. Okay, so that's how you solve it. So you find the MR, you already have that. You find the empirical mass, you divide them, and then you multiply with the compound, as Daniel said. Very good, Daniel. Yeah, so that is the way to solve this. Okay, so here's a question. This is from 2021. So it's saying that there's a compound. So it says compound B has 29.3% carbon, 3.7% hydrogen, 39% oxygen, 28% sodium. Okay, so we can easily calculate the MR. Okay. So carbon, hydrogen, oxygen, and sodium. Go on, everybody, calculate it. Molecular formula doesn't have any other names. There are other formulas though, but molecular formula, if it is for covalent substances, it will always be molecular formula. But if it is for ionic substances, it will be formula unit. There's a difference, okay? But just that, it still works like MR and all that. Formula mass is the MR for ionic compounds. MR is basically a general term. So for covalent substances, we say it's molecular mass. For ionic substances, we say it's formula mass. Find the empirical mass of this thing. Go on. Empirical formula of this thing, sorry. Okay. So this one's pretty straightforward. 29.3 over 12, 3.7 over 1, 39 over 16, and 28 over 23. अब इससे हमारे पास जो रेशियो आएगी वो obviously whole number तो होएगा नहीं. So we'll have to divide it by another number to get that. So I'll divide it all by the smaller number. So it'll give me 2. This will give me 3, 2, and 1. So yeah, okay, pretty straightforward. The order doesn't matter for now. A level में थोड़ा सा हम उसका ख्याल करते हैं. O3 में भी थोड़ा सा हमें देखना होता है कि कार्बन हमेशा पहले लिखते हैं. But order doesn't really matter at the moment. So C2H3 O2 Na. ठीक है. Okay, so I got a question. Let me see. Hold on. Can you try sending it again? I didn't get it. So either use this number or this number. So both of those would work. Yeah, I got it. Okay, so this is stoichiometry. Let me get to that. ये phase 5 वालों को फारिग कर लेना हम, फिर हम दिल लगा के पढ़ेंगे. Just kidding, मुझे पता है आप लोग. Okay, now here's the thing, guys. This question is really simple, but sometimes आपको आ जाता है, वो आपसे पूछता है कि ये आपको एक compound दे दिया. Find its empirical formula. So what do? You basically calculate. In fact, you don't calculate, you just count. Okay. So C5, you're actually just counting it. Okay. And hydrogen. So the rest of them are basically hydrogen. So hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So H10 and oxygen 1 and 2. So O2. So there you go. And this one is going to be our molecular formula. And this is also going to be our empirical formula, because you can't simplify this anymore. So basically all I did is calculate this. उसने बोला था कि आपने calculate करना है इसका empirical formula. Okay. So what did I do? I just calculated using counting. I count कि अच्छा मेरे पास 1, 2, 3, 4, 5 कार्बन है. मेरे पास 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 हाइड्रोजन और 2 ऑक्सीजन है. तो हो गया. ओके. अच्छा, ये क्वेश्चन मैं आपको करवाने लगा हूं जो कि जब आया था ना तो बच्चे बेचारे परेशान हो गए थे. So let me try if I can copy paste. Oh my God, handoff is not working. Anyways. Okay, you have to find the empirical formula of this compound. Go on. Look at how beautiful this compound is. कितना खूबसूरत structure है उसका. Just count it, guys. Start by carbon, then hydrogen, then oxygen. Okay, so I don't know if you have, but let's try counting it. So how would I do it in the exam? I will start counting. और किस तरह से count करूँगा? I will cancel the carbons out. I'll take a pencil and I'll start cancelling them out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 carbons हो गए. ठीक है? But do it with a pencil, not a pen, in case you miscount और आपको दोबारा से करना पड़े. Hydrogen. Now hydrogen I will not count. I'll just see कि कोई pattern है. So notice that every carbon has 2 hydrogens. है ना? Every carbon has 2 hydrogens. So based on that, I can easily figure out that I have 12 carbons. So ये 24 hydrogen होंगे. और oxygen कितने हैं? 1, 2, 3, 4, 5, 6. So I can easily do that I have 6 carbons. Okay. So that's what you do. Now this is the molecular formula. So जब इसका empirical formula होगा वो क्या होगा? C2H4O. There you go. Yeah, they can ask you this. It was in the O-levels exam और अक्सर students इसको देख के परेशान हो गए थे. But all you have to do is basically count. ठीक है? So that's what you should try to do. All right. So that is empirical formula, molecular formula, how you calculate that. Let me see कोई चीज इसमें रह गई हो तो. No, I think we have done all of it जो भी हमें required था. And yeah. अच्छा हाँ, एक तरह का क्वेश्चन एक दफा आया था. Let me recall. So I don't remember exactly what the values were, of course, but उससे हुआ ये कि क्वेश्चन के शुरू में उसने कहा था that compound contains 10 carbon atoms, and then उसने percentage formula सारा कुछ दिया हुआ था और आपसे कहा कि find the empirical formula and then state the molecular formula. So do you understand the setup? Let's say they gave you the idea that compound contains 10 carbon atoms, and then they gave you the percentage values, and they're like, okay, calculate the percentage mass. Okay, so hame empirical formula, let's say you calculated, you get C2H5O. Now go back to the question, it says 10 carbon. So now the molecular formula is going to be C10. And how do you get 10 here? You multiply by 5. So this is going to be C10H25O5. And there you go. That is the empirical formula and the molecular formula. Okay, so I think that is all for empirical formula and जो भी हमारे syllabus में था. I think इसके अलावा कुछ भी नहीं था, right? Can you correct me if I'm wrong? If there was any other question, any other topic? Moles. Mole conversion is pretty straightforward. किसी को उसमें problem है तो बता दें. Should I do mole conversion? Mole conversion बहुत simple है. You have to either you do the formulas or you do the ratios. Okay. और उसके लिए आपके पास बड़ा straightforward है. In case you have time, तो मेरी एक वीडियो है The Mighty Mole के नाम से. You can go over that. उसमें काफी questions हमने किए थे. So, but in any case, हम इसको फिर भी revise कर लेते हैं. So mole conversion को देख लेते हैं अभी. इसके बाद we'll go to stoichiometry and then yield. Okay. All right. So mole conversion. You have to remember the definition of mole for this. So just know that 1 mole compound, or any substance, in fact, not just compound, 1 mole has 6.02 times 10 power 23 particles. Okay, so those particles are a general term. They can be molecules, they can be atoms, they can be individual ions. वो कुछ भी हो सकता है, but जितना भी होगा ना 1 mole में 6.02 in 10 power 23 होगा. Doesn't matter which one it is, that's how many it is. Okay, so 1 mole is this, and this one is going to be also equal to mr grams. What this means is that you take 1 mole of anything and you will get mr grams. Okay, so that means you can easily weigh it. And not just that, if you have a gas and that gas or if you boil something, that will give you 24 dm cube. So that's the idea. You have 1 mole of anything, it will have 6.02 into 10 power 23 of individual particles. You group them up, you call it 1 mole. Okay, and then if you weigh it, that's mr grams, and if you boil it and you get the volume of that thing, that's going to be 24 dm cube. All right, so that is what it is. And now that we know this, we can use this idea to convert. हमें कुछ भी वो वैल्यू दे देते ना, हम उसको easily convert कर लेंगे. So let me get some questions for you. Okay, so this is an MCQ question. Mole conversion के ऊपर आया था. The question said that a student has 6.5 mole oxygen gas. I think पता नहीं क्या nitrogen gas कर लेते हैं चलो. What volume of gas syringe would be the most suitable? ठीक है, और अब क्वेश्चन से हमें देख के बिल्कुल नहीं पता लग रहा कि ये गैस सेंसेस का क्या ताल्लुक है, और ऑप्शन है हमारे पास 10 cm cube, sorry 10 dm cube, 100 dm cube, 200 dm cube, and 250 dm cube. So these are our options. Now, what they're technically asking us is, you just look at the unit, and the unit is the biggest hint that you can get. Okay? You will understand that because it's dm cube, that means volume. Because it's gram, that means mass. And because it is number of particles या कुछ भी, तो वो ये है. और अगर वो मोल की बात करें तो वो ये है. और अगर वो मोल पर डीएम क्यूब की बात करें तो वो कॉन्सेंट्रेशन है. Okay. So there are basically 5 units, and you will identify those units, and based on those units, you can easily figure out which one the answer is going to be. Yes, Ibad, your answer is absolutely correct. So let's see. Afeen, what do you want to say? Okay, so what we do is, because we know the volume, we'll calculate the volume. I know that 1 mole is 24 dm cube. That's the standard value. And every time you do the questions, all you have to do is just find the standard value, the value of 1 mole. So that's a step 1, value of 1 mole. And in second step, you do value of whatever is given to you. So the given value comes later. Okay. So 6.5 moles is going to be. So you do that and you will get your answer. Okay. So that will give me what? X is going to be 156 dm cube, and nearest value is this one. So I'll pick C as my answer. Okay. Sorry. Yeah. So we can easily figure out what the answer is going to be based on this. अच्छा, अब इसको जरा हम एक और क्वेश्चन देख लेते हैं. हाँ, ये एक बड़ा MCQ आया था जो बच्चे बड़े कंफ्यूज हुए थे इसमें. Okay, so there was a table, and in that table they gave you different compounds, and they said we have 1 gram of each compound. Which one contains the greatest number of oxygen atoms? बहुत अजीब सा क्वेश्चन था ये, और उसमें डिफरेंट कॉम्पाउंड दिए हुए थे, मतलब Cu2O, एल्यूमिनियम सल्फेट, सॉरी उल्टा लिख दिया, और क्या था, सोडियम नाइट्रेट, HCl. Okay, and then they gave you the MR. So 144 was the MR for this one. 342, 85, and 36.5. Okay, so we have 1 gram of each compound. Okay, so how do we calculate which one has the greatest number of oxygen atoms? अब ये MCQ है, which means we don't have too much time to solve this. तो उसके लिए करने का तरीका ये है that because they're saying that you have number of oxygen atoms, just calculate or just find out how many oxygen atoms you have. So इसमें 1 होते हैं, इसमें 12 होते हैं, इसमें 3 होते हैं, और इसमें तो 0 होते हैं ना. Get it? So basically, अगर अब try to understand this point. If I have 1 of this thing, it will have 1 of oxygen. If I have 1 of this thing, I have 12 of oxygen. And if I have 1 of this thing, I have 3 of oxygen. If I have 1 of this thing, I have 0 of oxygen. Okay. So based on that idea, all I need to figure out is how many moles of this thing do I have? How many moles of this thing do I have? How many moles of this thing do I have? and multiply it with this number at the bottom. That's all I need to figure out. So moles कैसे calculate करेंगे? Moles का एक बड़ा simple सा formula होता है, mass over mr. Okay, I have 1 gram, so 1 over 144 इसके moles आ गए, 1 over 342 इसके moles आ गए, 1 over 85 इसके moles आ गए, और 0 over 1 over 36.5 तो इसके moles आ गए. Now we multiplied with जो भी इसमें ऑक्सीजन एटम्स की बात हो रही, क्योंकि उसने ऑक्सीजन एटम्स का बोला है हमें, तो इसके अंदर 1 से मल्टीप्लाई होगा, इसमें 12 से मल्टीप्लाई होगा, इसमें 3 से मल्टीप्लाई होगा, और इसमें 0 से मल्टीप्लाई होगा. ओके, एंड बेस्ड ऑन दैट वी कैन इजीली फिगर आउट व्हाट दिस इज गोइंग टू बी. अब्दुल्ला, मैं आपको रोकूं अगर आप खुद से नहीं हो रहे तो. You need to pay attention, everybody. All right, so this is what we are going to get, and whichever is the highest, that's the one we are going to take. Okay, so that was also a difficult MCQ that was in the exam sometimes. मैंने देखा था. Let's see. Mole conversion के कोई और questions? हाँ, एक question last year आया था. It was कि उन्होंने, so the question was phrased this way, that calculate the mass of 48 dm cube oxygen at room temperature and pressure. They always give you room temperature and pressure. They don't ask you about any other value because वो हम A levels में पढ़ते हैं, O levels में नहीं देखते उसको. Okay, so based on this, all I need to do is, again, I told you the method. You always put the value of 1 mole. So 1 mole, because you're talking about oxygen gas, what's the volume of 1 mole of oxygen? 24 dm cube, because 1 mole of any gas will be 24. Very good, Daniel. And then you have to calculate the mass. So calculate the mr of oxygen. So 1 mole of anything is just mr grams. Okay, and remember, because this is oxygen gas, it's going to be O2. If it was nitrogen gas, N2. And any halogen, that will be that thing 2. So for oxygen we have O2, so it's going to be 32 grams. So the first line is always the value of 1 mole. So 1 mole is 24 dm cube, that is 32 grams. And then I have 48 dm cube, that's going to be x grams, cross multiply, and that gives you 24x equal to 32 times 48, and then x is equal to 32 times 48 over 24, and that will give you 64 grams. So that's a pretty straightforward question. ठीक है, तो वो ऑक्सीजन हो जाए, नाइट्रोजन हो जाए, कोई और कंपाउंड हो जाए, एक ही बात है. ठीक है, उसमें कोई ऐसा प्रॉब्लम नहीं होनी चाहिए. आई थिंक इसी तरह के क्वेश्चन आते हैं मोल कन्वर्जन के. लेट मी सी अगेन, कोई पास हुआ में रिसेंटली. Yeah, those are the ways they ask you about these questions. Okay, so that is mole conversion. You just take, so remember the method. You start with one, the first line is always value 1 mole, and whether it is volume, mass, whatever it is, ye wo hoga, and the next one will be the value that is given for whatever the volume is, whatever the mass is, whatever, anything that they're given us, hum usko dekh lenge. All right, so that was mole conversion. So I think phase 5 boys, आपका syllabus तो यहाँ तक ही था. Okay, so you're more than welcome to stay if you want to, but I think we have covered all the topics that you had in your syllabus for the October test. Okay, so it was just this. It's pretty straightforward, very easy, and I wish you all the best. Okay, yeah. Now let's get to business. क्या बोलते हैं? Let's get down to business. Yeah, बाकी करते हैं जो करने वाली चीजें हैं moles में. So that is stoichiometry. Now the idea of stoichiometry is simple. You have to just understand कि stoichiometry का method अगर आपको आ गया ना, तो आपसे बाकी भी हो जाएगा, जितने भी इसके क्वेश्चन हैं. You just have to understand the key idea. And the key idea is that every question will give you information about one thing, and they will ask you information about the other thing. तो पहली बात तो ये कि हमारे पास हमेशा एक सब्सटेंस होगा और उसकी वैल्यू मांगेगा, और एक दूसरा सब्सटेंस होगा and they will ask you of the value of that one. It's always, it will always be like this. Then in the first line, you have to write values for 1 mole. Okay, that's what you have to do for the first line. तो अगर वो आपसे कहते हैं ना mass, तो आप लिख देंगे mr. अगर वो आपसे कहते हैं ना वॉल्यूम, तो आप लिख देंगे 24. वो आपसे कहता है मोल, तो आप लिख देंगे 1. वो आपसे कहता है नंबर ऑफ पार्टिकल्स, आप लिख देंगे 6.02 into 10. Basically, you will always write the value of 1 mole in the beginning. ठीक है? The first line. And then in the second line, you'll put the given values. ठीक है? अच्छा. 2 points that you need to remember before you start a question. Okay? Do you want me to repeat it? Sure. So the idea of stoichiometry is they always give you information about one thing and they ask information about the other thing. And both of them will be coming from the equation. They will give you the equation. If they don't, you can form the equation. But I understand कि अभी आप लोगों का मतलब I don't think you are expected to make equation at this point. So you start with identify the substances from your equation जिसकी उसे information दी हुई है, and you identify the substance जिसकी information they have asked you of. So you just write them like that. For the first line, it's always going to be the first line. You write the value of 1 mole, और 1 mole की value मैंने आपको बताई. It was always 1 mole is this many particles. If they ask you for particles, if they ask you for mr grams, so it's mass की बात हो रही तो mr grams, और volume की बात हो रही तो 24 dm cube. ठीक है, तो वो आप यहाँ पर लिख दोगे. And remember, जो बैलेंसिंग इक्वेशन में आप नंबर्स लिखते हो ना, वो यहाँ पे नहीं आएंगे, because it's value 1 mole. 1 mole is independent of के वो बैलेंसिंग इक्वेशन में क्या हुआ. But then in the second line you write the given values, और उसमें आपके पास बिल्कुल जो भी आप कॉपी करके आए हो ना वो यहाँ पे होंगे. ठीक है, so I'm going to give you an equation. Yes, in your syllabus O levels you just do RTP, you don't do any other temperature and pressure. It's just RTP, so it's always 24 dm cube. Okay, so I'm going to solve a few questions from past papers that I have, और उसको हम करेंगे. But before we go into that, there are 2 points that you need to remember. For solutions, only moles can be compared. Which means if you have solutions, you can't use MR, you can't use 6.02. You can't do that. You can't use 24 dm cube. You have to do moles. And for that, you have the formula N equal to CV. Number of moles is concentration times volume. That's the first step. First thing that you have to remember. ठीक है? So ये आपको एक चीज आ गई. Second, if values for 2 or more reactant are given, find limiting reactant first. Okay, if the values of 2 or more reactants, मतलब usually वो आपको एक reactant की information देगा या एक product की information देगा, दूसरे की मांग लेगा. But अगर वो आपको 2 की information दे देता है, that's a big hint that this is a limiting reactant question. And you have to first find the limiting reactant, and then you have to move on to whatever the question is asking. Okay, so that's the second step. Next, find yield at the end. Solve the question. इस तरह से stoichiometry का पूरा question solve करना है. और अगर कहीं पे उसने yield मांगी है ना, तो it will be right at the very end. And अगर आपसे उसने purity का कहा है, तो purity in the beginning. तो yield की बात होती है, तो you will solve it at the end of the question. Purity की बात होती है, you will solve it at the beginning of the question. These are some hints that you can use to make sure that you're getting the question right. Okay. So I will give you examples of each of them so that you don't get confused कि ये यहाँ पे क्या हो रहा है और यहाँ पे क्या हो रहा है. We will solve them. So let's start with this question. They've told us that magnesium reacts with HCl to give magnesium chloride and hydrogen gas. Okay. In case you need to know how to balance equation, I'll give you a short video on that. I think YouTube पे मैंने पहले से बनाई हुई है, so आप उसको देख लेना. All right. Okay. So now the question is saying that. Okay, so that's a question. And they can also add something to this. They can also say with excess HCl. This word excess means ignore. That's what it means. Okay. So you ignore HCl. हमने HCl को भूल जाना. We will just focus on magnesium and hydrogen. And those are the two substances. I told you, we are going to look at the two substances. That's what stoichiometry is all about. So we'll look at the two substances, and that is magnesium and HCl. Oh, sorry, magnesium and hydrogen. So we copy that from the equation. Magnesium, hydrogen. We copy that. First step of the question was to give the value of 1 mole. Okay. So what is the mass of 1 mole magnesium? Mass क्यों? Because gram है. इसकी volume है तो dm cube लिखेंगे हम. So mass of 1 mole is 24 grams. And what is the volume of 1 mole hydrogen? 24 dm cube. Interestingly, वो same आ गई है. But that's just a coincidence of the question. So if I have 1.68 of this, I'll get x of this, and x is going to be also 1.68 dm cube. और मेरा आंसर आ गया. ठीक है? Okay, let me take another question. Somebody sent a question. Let me solve that. Okay, so the question is, sorry, a sample of 25 cm cube of 0.5 mole per dm cube aqueous ammonium nitrite is heated. Calculate the volume of nitrogen formed. Okay, so that's a question that we have. Now, you will not be expected to solve this question without an equation. Okay, and the reason for that is that when they react, ammonium nitrite, when it reacts with the, मतलब वो डिकम्पोज होता है, तो वो आपने अभी पढ़ा ही नहीं है कि वो कहाँ से होता है. ठीक है. So basically ammonium nitrite, and that's again not, you're not required to come up with this equation at the moment, but basically ammonium nitrite breaks down and gives you nitrogen gas and water. Okay, let me get the balanced equation. I don't want to spend time balancing it. Yeah, so it gives you ammonium nitrite, breaks down and gives you nitrogen gas plus water. Directly तो नहीं करता होगा, but anyways, जो भी है, ये हमारे पास equation आ गई. So the two important parts that we have is, we have this part which is aqueous, उसकी state है aqueous. This is a gas, this is obviously liquid. Okay, and we need to figure out कि हमें कितना ये है और कितनी gas निकल गई. Now remember, I told you that if you have solutions, for solutions, only moles can be compared. Okay. No, Lena, percentage purity and percentage yield is different. Purity, you usually do that at the beginning of the question, yield at the end of the question. Okay, but the way to calculate this is same, because at the heart of it, they're both percentages. Okay, so I'm going to copy this part, NH4NO2, And I'm going to copy this part, N2. Okay. And because this is a solution, I can only compare its moles. So I'll take 1 mole because equation में 1 दिया हुआ है ना उसने. And what is the value of 1 mole of nitrogen gas? 24 dm cube. Okay. Now, how many moles do I have? Moles is concentration times volume. So 25 over 1000, because of cm cube, I need to convert it to dm cube, multiply by 0.5. That is concentration times volume. That's going to give me x of this. So I'm just going to cross multiply it. X is going to be 24 times 25 over 1000. Put it all in a calculator. So 0.3 dm cube. And there you go. That's my question. Pretty straightforward. Okay. Let me try another question. Any question on this, by the way? Anybody who doesn't get it? Actually, I don't get. How did you get 0.0125? Okay, here's a question that I'm going to give you. Try doing this. Dilute sulfuric acid reacts with sodium hydroxide. Okay, so again, you're not expected to form the equation, I guess. So now this is a 4-mark question. I'm not sure if you'll be asked to balance the equation. I'm not sure about that. But to get a quick review of how to balance equation, we can do that. I'll send you a video on that. Okay, now, can anybody read the question? Tell me what the big hint in this question is. Yes, very good, Ashna. Because they have given us information of 2 reactants, this one as they've given it here, and this one as they've given it here. This is a limiting reactant question, which means we need to first figure out what is the limiting reactant. So how do you calculate that? So we'll first find limiting reactant, and then we'll solve the question. Okay, so how do you calculate the limiting reactant? You take the value of one thing and you compare it to the value that is given for the other thing. I'll say that again. You take the value of one thing, and using that, you figure out how much of this you need and whether it's more or less than the value that you have. Okay, so let's do it. I have n equal to Cv of H2SO4. So I'll just copy that. So H2SO4 and 2 NaOH. Okay, so H2SO4 is a solution. So I'll just take the mole, 1 mole, reacts with 2 of this. So this is grams. So I'll take the grams. So that's going to be 23 plus 16 plus 1, 40. Yeah, 40 grams. So that's telling me that 1 mole of H2SO4 requires 80 grams of that thing. I have 45 over 1000 times 0.2. So 45 divided by 1000 times 0.2, that is 0.009 gives me x. So x is going to be 0.009 times 2 times 40. So that's 0.072, sorry, 0.72. So that's telling me that I need 0.72. And at the time, if I have 0.72, all of this will be used up. I have more than that. So clearly 0.72, because it's less than what I have, sodium hydroxide, this thing is in excess. But I told you, whatever is in excess, you ignore it. And now this is the one that I'm going to work with. So the question said, calculate mass of water formed. I have this, I have this. Now the question is pretty straightforward. Okay, so I'm going to take H2SO4. So now I'm getting the answer that I'm looking for. So I'll copy H2SO4. I'll copy water again from the equation. I'll put the value of 1 mole, and 2 times 18 grams. Okay. I have the given value, which I already just calculated, 0.009. That will be x. So x is going to be 2 times 18 times 0.009. So that comes out to be 0.324 grams. Okay, not so bad. We calculated it. Okay. Let's take another question. I'm looking for a question. Okay. Okay. I'll give you the equation. All right. Can you attempt it? Okay, Dania. Second part of this question is about purity. Okay, so again, in this question, we have this one, we need to find the mass, and we have this one, which we has the volume. So that's what we're looking for. So I'll just copy these parts, CaCO3 and CO2. 1 mole of this thing is 100 grams. I just calculated it. In fact, mujhe to yaad tha. So this is 100 grams, and this one is 24 dm cube. You can easily calculate it. Calcium ka 40 hai, carbon ka 12 hai, oxygen ka 16 times 3. Okay. And I have X, and this is 16.8 cm cube. That means you have to divide by 1000 first. So when I do that, I get, now I cross multiply. So 100 times, and then this 24 will come here and divide it. 300, 10 bach gaya. And so I'm getting 0.07 grams. That's what I'm getting. Okay, so 0.07 grams. Okay, so that's how many grams you need. Now here's the thing. The second part of this question is, Okay, so let's try to understand what they're saying here. They're saying that calcium carbonate, which is just calculated, it is found in limestone. And you have limestone that is 65% pure. They've already told you the purity. You have 0.07 grams, and they've told you that the thing where you get it from is 65% pure. So what mass of that will you need? Now, for purity, I would suggest we use a ratio method, and that's pretty straightforward. That if this was 100% pure, I will need 0.07 grams. So if it is 65% pure, I will need X grams. No, wait a minute. गलती हो गई है. I need 0.07 grams. And that is coming from 65% of the thing. So I'm saying कि अच्छा ये 65% pure था, तो उसमें से मुझे 0.07 मिला. If it was 100%, how much will I need? Do you get it? That because this is 65% pure, I got just 0.07 grams. If it was 100% pure, how much would I have gotten? So I multiplied 65x is equal to 0.07 times 100. So x is going to be just divide it all. 0.108 grams. Make sure you give a value to 3 significant figures. Now, in case you want a formula, then that's pretty straightforward. The formula would be given mass over total equals percentage purity over 100%, or you can also just multiply it by 100% here. So basically what I'm saying is that percentage purity is given mass over total into 100%. So अगर मैं इसको इस तरह से करूं तो percentage purity is 65%. Given mass is 0.07 grams. Total mass is not known into 100%. Okay, and I'll just obviously manipulate it to figure this out. No, 0.07 grams was the mass that we had. It's not moles. Okay. Some books also phrase it differently. Like instead of saying given mass over total, they'll say percentage purity equals pure over impure into 100%. And that, of course, that's also fine. Okay. Yeah, Ashna, you're right. That's the one. Okay. So you can easily use that. Okay. I'm going to give you another question. I want you to solve it. Okay, so yeah, I do expect that you will be provided with the equation, because if you're not, I don't expect you to be able to do it right now, because obviously हालात हमारे सामने ही हैं. So your question is absolutely right, Lian, that many students do get confused as to which two compounds to take. So remember, one is obviously the one that you have here. जो question उसने पूछा होता है. Okay, but for the other ones, you have to find the limiting reactant. Okay. So as Ashna said, you find the limiting reactant first. So let's do that. Because I have information of both the reactants, that's a clear hint that you have to find the limiting reactant. So I'll do that. So I have C3H7COOH, that thing, I'll copy that. I have Na2CO3, I'll copy that. And for this one, I have the mass, which means I'll need to calculate the MR. Okay. So, okay, that's going to be a big value. So 3 times 12 plus 7 plus 12 plus 32 times 32 plus 1. So that's 88. So 2 times 88 grams. Okay. And for this one, this is a solution. How do I know? Because I have concentration here. Okay, so this is just going to be 1 because I get only moles, and the moles we get from the equation. Okay, so now I'll just take X for this, and I have C into V for this. So 56 over 1000 times 0.5. So I get 2 times 88 times 56 over 1000 times 0. I'm just copying all of that. I'm just moving all of that. Okay, equals to X. So I'll just put it all in the calculator. So 4.928 grams equals X. Okay, so this is what I need for this to be completely used up. That's what the question is telling me, that I need this much grams and this will all be used up. This is sufficient for that. But I have more than that. That tells me that C3H7COOH is in excess. Because remember, the one that I run out of first, that's the one that we are going to obviously like the limiting reactant. So in this case, our limiting reactant is this. So I'll ignore this, the one in excess. And now the question is saying, find the volume of carbon dioxide. So this is the one compound and this is the other compound. And now you solve the question. Yeah, there are multiple ways of solving this. Another way that many students do, and which I also personally like the best, is that आपको उसने बोला ना limiting reactant है, आप दोनों से निकाल लो question. Instead of finding limiting reactant first, आप इससे भी calculate कर लो और इससे भी calculate कर लो. And the one that gives you a lower value, that is going to work. How about that? So you calculate the answer using both the reactants, one at a time, obviously. And then based on that, you figure out जो भी छोटा होगा, जो भी lower value है, that is going to be the answer. So you can do that. Another way that we do is we first find moles of this, then we use the ratio method. We find moles of this, and then we multiply that by 24. So I call that a 3-step process. And of course, that's also absolutely right. You find moles of this thing, you find moles of this thing, then you find volume of this thing. So I think actually that's the one you have done. And that's perfectly fine. Remember, method doesn't matter. The important bit is that you show your steps and that you give the right answer. Those are the things that examiner is going to mark. Examiner is never going to be like, अच्छा इसने ये method use किया तो इसको मैं ज़्यादा marks दे दूँ. No, they are not biased like that. So you have to remember that whatever you are more comfortable with, you go with that. Okay? So that's stoichiometry. और हाँ, एक yield का question कर लेते हैं. So yeah, so here's a question. Yes, Ashna, if you have a limiting reactant question, you have to ignore the excess substance. Afin, you're right. This method, I basically made this method myself when I was a student. So I have been using this. Then I showed it to the Cambridge examiner when I met them. And they said, हाँ, this is perfectly fine. We will mark it and there's nothing wrong with it. So इस वजह से I've been using this since then. So I know that almost every teacher teaches it in a standard way, that you first find moles of one thing, then you find moles of the other thing, and then you find your answer. And there is absolutely nothing like incorrect or wrong about that. That method works like a charm. But ये थोड़ा सा मेरा personal इसके अंदर ना pride involved है इसके अंदर, तो इस वजह से. Anyways, so let's do this question. This is a question of percentage yield, and I told you that whenever you have the yield question, you basically do it at the end. I will solve the previous question using that method, the one that you're saying, but isko dekh lete hain pehle. So we keep the yield for the end of the question. So abhi hum yield ko dekhe bagair isko solve karenge. Imagine if the question was just ending over here. Ki calculate the mass of iron formed from 2500 grams of iron oxide. ये इतना question है. Ignore the yield part and let's just solve it. So we know कि हमें iron का mass निकालना है and iron oxide's mass is given. So we'll just calculate that to Fe2O3. Oh God, what is it? Yeah. 2 Fe2O3, 4 Fe. Okay, so you put the values of 1 mole. So I have grams, right? So 2 times, I'll calculate the MR. 160. And this one is 4 times 56 because 56 is the value of 1 mole. And now that I have the values of 1 mole, I'll put the given values. So this is 2500. This is X. So I'll just calculate it. So cross multiply 2 times 160 equals, sorry, X equals 4 times 56 times 2500. So X equals to 4 times 56 times 2500 over 2 times 160. Put it all in a calculator. So 1750 grams. So that's our answer. But that is the answer, remember, if you ignore the yield point. Why? Because when you ignore it, you're basically saying, oh, this is 100%. The yield is 100%. That's what it means to ignore the yield value. So now we will calculate it considering this. Okay. So if 100% was the yield, then I would have gotten 1750. But the yield is 80%. So I'll get X. Get it? I think technically we are comparing the moles. You see these 2 and 4 here, they have taken care of the comparison. मैं अभी करवाता हूँ उसको. Just give me a minute. Let me just finish this and फिर मैं आपको उस method से करवा देता हूँ. Because you see, method doesn't matter. Showing all the steps and giving the right answer, that's what matters. So we just solve it. X is going to be 1750 into 80 over 100. And obviously, whatever that comes out to be. 1400 grams. Okay, so there you go. That's our answer. Now, let me solve it using the method that other students are more comfortable with. So that method is basically a 3-step approach to this. So here's how it goes. You have this. You start with substance 1. I'll call it S1. So it's the first substance, the limiting reactant. You calculate moles of that. That's your first step. Then from there, you calculate moles of the other thing. And from there, you find your answer. So that is the 3-step approach that I think you're talking about. So here's what we can do. Let's try to solve this question using the same, and then we'll solve other questions. I have 2500 grams of this thing. So whatever you have the value of, that's your substance number 1. And whatever you want to find the value of, that's your substance number 2. Okay. So let me find moles of the first thing. So again, remember this method is you first find moles of the first thing. So it is going to be 2500 divided by 56, because that's the value of 1 mole, mass over MR. That's the formula I'm using. So 2500 divided by 56 gives me 44.64 moles. Now notice what I did. I did not round it off to 44.6. I wrote it to 4 significant figures, because when you're solving a question, write to 4 significant figures, and for your final answer, round it off to 3. Okay. So now that I'm here, so it's a journey. I started here, got here. Now I'm moving on in life as well. So I have moles of one, moles of the other. So 2 compares to 4. Okay. So 44.64 compares to X. So that will come out to be, you cross multiply, X is going to be 4 times 44.64 over 2. So that is going to be 89.29. Okay, moles. What is this telling me? This is the moles of the second thing. I'm here now. Okay, I started here. I'm here now. And the third step, I have to find the answer. So I need to find the mass. So number of moles is mass over MR. Number of moles is 89.29. Mass is unknown. MR is, oh my God, I made a mistake here. The value given was for Fe2O3, not iron. तो MR गलत यूज कर लिया मैंने, my bad, sorry. So MR इसका क्या था, 160 था. So 2500 divided by 160, that will be 15.625. 15.625. That will be 31.25, or 31.25 equals mass over MR, AR in this case. So 1750 grams. See, same. And now because this is when you have 100%, so I have 80% yield. So I'll use the formula of yield, that percentage yield is calculated value or theoretical value. So sorry, what was it? What's the formula that you're using? क्या बोलते हैं उसको? Practical value over theoretical value. Okay, so practical over theoretical into 100%. I think that's what it is. So I have 80% yield. Practical is, I don't know. Theoretical is 1750 into 100%. So now it's basic algebra. So it will come out to be 1400 grams. Okay, so I hope that's clear as to how you solve this. Of course, this method is step by step. You've broken all the process down, and this is perfectly fine because it gives you the same answer. So it's up to you, whichever method you prefer, whatever your little heart desires. Okay. Yeah, so that is moles, stoichiometry, all of that. If you have any questions, you can WhatsApp them to me. I'll be happy to solve them yet. I would suggest that try to solve MCQs. What I'll do is I'll quickly send you 3 worksheets that I made. And if you do those worksheets, and I already have the solutions for those, so you'll be fine. मतलब आपको पूरा mole मतलब throughout 100% of this chapter, उन 3 worksheets में कर लेगा. There's this startup. उनके लिए मैंने वो videos बनाई थी, so they have allowed me to use that. So let me send you those. Okay. Any specific topic you should focus on? I think the topics already are very few. So there's nothing in particular that I would say, oh, you must do this or you must do that. Just make sure that the method, whichever you're following, you're more comfortable with that. So don't stick to a method just because you think ye mujhe karna chahiye. Do the one that you're able to do it. Okay, that's what matters. And of course, try to always write all the steps that you have. And of course, these 3 steps, these 3 points for stoichiometry, they will really, really help you out. All right, wishing you all the best. I will be posting videos and these notes in the group right now. So yeah, you'll get it there. Okay, take care. Hafiz.